Hello everyone. Today I'm going to discuss here about the volume of combination of solids. As in our last class we had discussed about the surface area of combination of solids in the chapter surface area and volumes. Now in today's session we'll see that how we can find out the volumes of combination of solids in different situations. Now there are some common situations which we'll discuss here first before moving on to the question, and then we'll be seeing how the questions are. So moving to the first part here, let's talk about some of the common object which we'll be solving the question on. The first one is here a hemispherical depression in a cube. So in this case, if we have to find out the volume, remember the volume is a very straightforward concept that if you are hollowing out something, that means you will have to subtract that volume. If you are combining the two solids, then you'll have to add the volumes. So it is a straightforward concept. So here the first object is a cube from which a hemisphere has been cut out. So here in this case, we know that for maximum diameter, the edge length will be equals to 2r, and so r will be a upon 2. In this case, the volume will be equals to the volume of cube minus volume of hemisphere. So it will be a cube minus 2 by 3 pi r cube. If you talk about the second case where a hemisphere has been kept at the top of the cube, we'll have volume equals to a cube plus 2 upon 3 pi r cube, where again the radius is half of the edge length. Next we'll talk about a cone kept on a hemisphere. So in this case, if you'll take the radius of the cone and the hemisphere be r as it is same, and the height be h, then the volume of solid will be equals to volume of hemisphere, which will be 2 by 3 pi r cube plus volume of cone, which will be 1 upon 3 pi r square h. Moving to the next part where a cylinder is kept over another cylinder. So if we take the radius of the upper cylinder as r, and for the lower cylinder if we'll take capital R, then here the volume will be equals to pi r square. Let us suppose h is the height of the upper cylinder and capital H is the height of the lower cylinder. We'll get pi r square h for the upper cylinder volume and pi capital R square into capital H for the lower cylinder, which we can write it as pi into r square h plus r square h. Next, when you talk about a conical depression cut out from a cylinder, so in this case the radius is r, and if we'll take the height of cylinder, which will also be the height of cone here, as in this case we are cutting a cone of maximum height, which will be height of cylinder. So the volume will be equals to volume of cylinder, which is pi r square h, minus volume of cone, which is 1 by 3 pi r square h. Further we can write it as pi r square h 1 minus 1 by 3, which will be equals to 2 upon 3 pi r square h. The next case is two hemisphere has been cut out from a cylinder. So in this case the volume of the remaining object will be equals to volume of cylinder, which is pi r square h, where h is the height of cylinder and r is the radius of cylinder, which is also the radius of hemisphere, minus it will be 2 into 2 upon 3 pi r cube. As we have two hemisphere, so we have to multiply it by 2. This will become pi r square h minus 4 upon 3 pi r cube. Now then we can take pi r square common and we can simplify it by substituting the value as per the question. Now we'll see some question based on it. So here the first question is, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeters. So in this case, it is given that diameter of the model is 3 centimeter, which implies radius will be 3 upon 2 centimeter. Here, the radius is same for the cone as well as for the cylinder. Its height is 12 centimeter. So in this case, if you talk about height of this model, that is 12 centimeter. If each cone has a height of 2 centimeter, so in this case, the height of cone is 2 centimeter. Find the volume of air contained in the model that Rachel made. Assume the outer and the inner dimension of the model to be nearly the same. As here the height of the cone is given, we can find out the height of cylinder. So here height of cylinder will be equals to 12 centimeter minus 4 because cone are attached at both the end. So here height of this part is 2 centimeter and height of this is also 2 centimeter. So height of cylinder will become 8 centimeter. Radius already we know it is 3 by 2. So let's find out the volume of the model. So volume of model will be equals to volume of cylinder plus 2 times volume of cone. Volume of cylinder is pi r square height of cylinder plus 2 into volume of cone will be 1 upon 3 pi r square into height of cone. Now from here we can take pi r square common. We'll get height of cylinder plus 2 upon 3 height of cone. Now pi value is 22 upon 7, radius is 3 upon 2 which will become 9 upon 4 into height of cylinder which is 8 plus 2 upon 3 and height of cone is 2 centimeter which will be equals to, here we can simplify it, it is 2 times, this will be 11. So we'll have here 11 into 9 that is 99 upon 14 into we have 8 plus 4 upon 3 which will be 99 upon 14 into it will be 8 into 3 24 plus 4 that will be 28 upon 3. On cancellation we can cancel it 2 times, this is 33. We'll get the value of it as 66 centimeter cube. So that will be the volume of air contained in the model. The next question is, a gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamun, each shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. In this case, the length of the gulab jamun is 5 centimeter and it is given that the radius is 1.4 as diameter is 2.8. So radius of the other end will also be 1.4 centimeter. In this case, radius will be 2.8 upon 2 which will be 1.4 which also can be written as 14 upon 10 centimeter. Here, height of cylindrical part will be 5 minus 2r which will be 5 minus diameter 2.8 which will be 2.2 centimeter. Now, In order to find out the volume of sugar syrup, we'll first find the volume of 1 gulab jamun, then we'll multiply it by 45 in order to find the volume of 45 gulab jamun, and then we'll find 30% of it. So here, volume of 1 gulab jamun is equal to volume of cylinder plus 2 times volume of hemisphere, which will be volume of cylinder is pi r square h plus 2 into volume of hemisphere is 2 by 3 pi r cube. Here we can take pi r square common, it will be h plus 4r upon 3, which can be written as pi r square into 3h plus 4r upon 3. Here first we'll substitute only the value of h and r in the bracket. Later on we'll find out the exact value. So we'll leave pi r square as it is. 3 into h, so h is 2.2, which will become 6.6 plus 4r, that will be equals to 5.6 divided by 3, which will be pi r square into 12.2 upon 3 cubic centimeter. Now we'll find volume of 45 gulab jamun, which will be equals to 45 into pi r square into 12.2 upon 3. Here we'll cancel this 45 15 times. The value will be 15 into 12.2 pi r square centimeter cube. Now we'll try to find out what is the volume of sugar syrup. So volume of sugar syrup will be 30% of volume of all the gulab jamun, that is 15 into 12.2 pi r square, which will be equals to 30 upon 100 into 15 into 12.2 into pi, which will be 22 upon 7 into r square. So radius is 14 upon 10, it will become 196 upon 100. Now here we can do some cancellation. 7, it will cancel 2 and 8, that is 28 times. 0 will get cancelled. 5, it will be 3 times. This is 2 times 2 will cancel this 28, 14 times. Now on simplification, we'll get the value of it as 338.18, which we can write it as approximately 338 cubic centimeter, which will be the volume of sugar syrup in all the gulab jamuns. The next question is, a pen stand made of wood is in the shape of cuboid with 4 conical depressions to hold pens. The dimension of the cuboid are 15 cm by 10 cm by 3.5 cm. The radius of each of the depression is 0.5 cm and the depth is 1.4 cm. Find the volume of the wood in the entire stand. So in order to find the volume of the wood in the stand, as we know that here 4 conical depression has been made in order to hold the pen. So what will be there? We will have to find the volume of the remaining solid by subtracting the volume of 4 conical depressions. So here if you talk about the conical part of the pen, it is given that the radius of the depression, if you will take it as small r, which is 0.5 centimeter, which we can write 1 upon 2 centimeter, and the depth of it is h, which is here 1.4 centimeter, which will write it as 14 upon 10 centimeter. Now if you talk about the volume of wood. Now the wood is in the shape of cuboid in which the conical depression has been made. So we can say, therefore, volume of wood in the stand will be equals to volume of cuboid minus 4 into volume of cone. Volume of cuboid, it is LBH minus 4 into volume of cone is 1 by 3 pi r square h. Length is given, it is 15, breadth is 10, height is 3.5 minus 4 upon 3 into pi, 22 upon 7, radius is 1 upon 2, so square of it will be 1 by 4 into height, which is 14 upon 10. Now we can cancel 7 and 14 two times, 4 and 4 will get cancelled. The value will be 15 into 10 into 3.5. So 3.5 into 10, that is 35, into 15, we'll get it as 525 minus 44 upon 30, which will be 525 minus 1.47, which will be equals to 523.53 cubic centimeter. So that will be the volume of the remaining stand after the conical depression. The next question is, a vessel is in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim when lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel. 1/4 of the water flows out. Find the number of lead shots dropped into the vessel. So here, the lead shots are in the form of a sphere. It is given that the vessel is in the form of inverted cone. Its height is 8 cm. So here the height of cone is 8 cm and the radius of it is 5 cm. It is filled with water up to the brim when lead shots, each of which is a sphere of radius 0.5. So in this case, the sphere part is having a radius, let us suppose it is R1, is equals to 0.5 centimeter. So here R1 is half centimeter. We have to find out the total number of lead shots. So let the number of lead shots be n. Here it is given that 1/4 of the water flows out. Now this water flows due to the volume of lead shots as it is being dropped into the vessel. So here we can say that according to the question, we can write n into volume of 1 lead shot will be equals to 1/4 of volume of cone, which means n will be equals to volume of cone, which is 1 by 3 pi r square h upon 4 into volume of 1 lead shot, that will be 4 upon 3 pi r1 cube. Here 3 and 3 will be cancelled. We can cancel pi and pi. So the value of it will be r square, which will be 25 into h is 8 divided by is 4 into 4 into r1 cube. The value of r1 is half, that means it will be 1 upon 8. Now we can cancel further. This 4 will cancel it 2 times. This 4 and 8 will get cancelled 2 times. So the value of it will be 25 into 4, that will be 100. That means 100 lead shots were dropped into the conical vessel. The next question is, a solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole given that 1 cubic centimeter of iron has approximately 8 gram of mass. Use pi equals to 3.14. So in this case, the height of the lower cylinder, let it be h, and the upper cylinder be small h. The radius of the lower cylinder be capital R and the upper cylinder be small r. So here the value of h is given 220 centimeter and the radius of it will be 12 as diameter is 24. For the surmounted cylinder, we have height as 60 centimeter and radius is 8 centimeter. So here the volume of cylinders will be equals to the volume of lower cylinder plus the volume of upper cylinder, which will be pi r square h plus pi r square h, which will be equals to pi into r square h plus r square h, which we can write it as pi into capital R, so that is 12 into 12, that will become 144 into height is 220 plus small r square, that is 64 into 60, which will be equals to pi into, on solving we'll get the value of it as 35,520. Now substituting the value of pi as 3.14 and multiplying it by 35,520, will get the value of it as 1,11,532.8 cubic centimeter. Therefore, mass of pole will be equals to the volume, that is 1,11,532.8 into 8 gram, which will be equals to 8,92,262.4 gram, which can be written as 892.2 kg approximately. The next question is, a solid consisting of right circular cone of height 120 centimeter and the radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and the height of it is 180 centimeter. Here height of cone is 120 centimeter and radius of cone, which is also the radius of cylinder and hemisphere, is 60 centimeter. Standing on a hemisphere of radius 60 is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder. So in this case, height of cylinder will be equals to height of cone, that is 120 plus the height of hemisphere, that is 60, so it will be 180 centimeter. Now the volume of water left in cylinder is equal to volume of cylinder minus volume of cone minus volume of hemisphere. In this case, the volume of cylinder, which will be pi r square height of cylinder, minus volume of cone, which will be 1 by 3 pi r square height of cone, minus volume of hemisphere will be 2 upon 3 pi r cube. We can take pi r square common. Height of cylinder is 180 minus height of cone, here is 120 upon, it is 3, minus pi r square we have taken common, it will be 2r upon 3, where the radius is 60, it will be 2 into 60 upon 3, which will be pi will substitute 22 upon 7, radius is 60, which will become 3600. It will be 180 minus, on cancellation, this will be 40. This will cancel it 20 times. So this will become 40 minus 40, that will become 80. It is 22 upon 7 into 3600 multiplied by 100, which will be equals to 11,31,428.57 cubic centimeter, which also can be written as 1.131 cubic meter. And that will be the answer of it. So this is all about this chapter as of now. Here we have discussed about the basics, following which we discussed about the surface area of combination of solids, and then we discussed about volume of combination of solids. That's all. Thank you. Take care, everyone.